Hi, everyone. I'm Peter Burns, an automation specialist with Turtle. I'd like to apologize in advance. Allergies have been messing with my throat today, so I might end up pausing to drink a little bit of water or take a cough. But that being said, let's dive into it. Uh, Today we'll be covering Ethernet IP and cabinet solution. Here's a quick little agenda of what we'll be covering today. Uh, First, what is the outcome, which is going to be panel optimization using the Ethernet IP and cabinet solution, a product overview, a product roadmap of where it's going, some expected business outcomes of also why you would want to use the Ethernet IP and cabinet solution, and then a few extra additional resources. So panel optimization. In traditional hardwired panel assemblies, these are inflexible, making it difficult and time-consuming to modify or expand systems without significant rewiring, with multiple wires running to every component inside the panel. This increases expenses related to commissioning, training personnel to wire up the panels, and maintain and troubleshoot intricate hardwired components. There is limited scalability, and adding new features or components often requires substantial redesign or installation efforts. There is also a lack of advanced monitoring capabilities, which can hinder quick identification and resolution to issues that are happening inside your panels with specific components. There's also no way to identify how old components inside the panel are, except if there's a detailed log. With the Ethernet IP and cabinet solution, this allows for end-to-end Ethernet connection over an OTVA network. These all use standard commissioning tools and integrated as other Ethernet IP and devices. So if you have programmed, say, a drive for a Studio 5000 in Studio 5000, it's going to be a very similar setup. There can also be distributed logic in cabinet components with peer-to-peer functionality rather than a centralized controller. So all the components in Ethernet IP can talk to each other directly. There's no need to have a controller in the panel. It is recommended, but it's unnecessary, as I will demonstrate later in this presentation. There is also predictive maintenance uh, for the attached components inside the panel. So every, say, 100,000 cycles, I'm not certain if that's correct, the contactor is supposed to be replaced. So uh, at around 100,000 cycles, you're going to get a notification in your um, controller that, hey, this contactor should probably be replaced. And we're going into a product overview now. So here are the main components for the Ethernet IP and cabinet solution. On the upper left of the photo, you can see this is going to be your gateway. This is going to convert your standard Ethernet cable into this single ribbon cable that connects all your devices. On this single ribbon cable, you can have up to 40 total devices, including the gateway, so 39 other devices. The maximum length of this cable is going to be 25 meters. So from here to your last component can be 25 meters away. All of these devices can be quickly assembled. I'll also try to demo that later, but these are snap-on clips onto this ribbon cable where they puncture through the ribbon cable and make connections to the wires inside. All this improves the compatibility and communication interfaces with the standard 800F panel components that are going to be your 22 millimeter operators, as seen down here, and your 100E contactors, which you can see up here, which the 100E contactors are low energy consumption contactors. So a little bit more about the gateway. This guy also is going to provide power for all the devices. So at the bottom, you can see this black plug that you're going to put in 24 volt here, and behind it are two RJ45 Ethernet ports. These guys are able to communicate over SIP routing and aggregate all your I/O into this one device. there's automatic IP address configuration for all your devices downstream of this node. This node right here, you're going to choose the IP address. All of the following devices are going to be standard, is going to create a subnet of your network past this device. So you can have repeat IP addresses, and the subnet is going to be your standard 192.168.1, and then start at 1, 2, 3, 4, all the way up to 39. And all that is automatic, so you don't need to worry about it. But if you do want it, you can go past 39. If you end up unplugging a device, it only will just actively support 39 devices at a time. The flat media cable is a 7-conductor. This provides both 24 volts, which will be 4 amps continuous, or up to 8 amps for about 100 milliseconds for when a contactor turns on, and you have that instantaneous inrush current. The communication is done between single pair Ethernet, which is going to be two little ribbon cable, two little cables in the center. All this is, and the closest you can put a device next to each other is about 50 millimeters, which are going to see these vertical black lines on top of along the length of the ribbon cable, and this darker black dots, long cable dots, is going to indicate what is upside of your ribbon cable as you install little end nodes. So this is how the 800F push buttons communicate with the ribbon cable. There are these modules. They look fairly identical, except the illuminated ones will have a little bit of a nose popping off of this black device up here. There's both, once again, illuminated and a non-illuminated versions. These are going to attach to standard 800F latch mounts. So, and you can put two standard contacts on the back of these. And the illuminated ones use LEDs with RGB, so you can have up to 8 different colors off of one button. I'll demo that a little bit later. And then these are the communication interfaces with your contactors. They range from 9 to 96 amps. They're front mounted, allowing the ability to have additional auxiliary contacts still mounted on the side of your contacts. They're built-in interlocks for reversing contactors, and these can be applied to either 2 or 3 component standard starters. So a little bit more about the starters. There's basic motor control for reversing and non-reversing. As you can see in this photo, there's two little cables running. This will just indicate back to your device that your overload has blown, or your contactor has blown. For the smart motor controller, which is new, there is now a small 3-wire cable that can connect directly to your overload and feedback the type of event status that are causing these breaks, say like under voltage warnings, phase loss warnings, jam warnings. So you can get all this new available data from your overload back to your PLC, and you can also even remote start your overloads from your PLC without a local person restarting it. And additionally, there is now a inline boost. This is going to provide an additional 4 amps continuous, or up to 8 amps per surge. This is going to be mostly for if you're running multiple, say 96 amp contactors. Well, these are going to have higher inrush current. So if you start, say, 10 of these 90 amp contactors at once, it might draw more than 8 amps. So you throw an additional one of these power boosts in the middle of your flat media cable line, and then this will provide extra power to the devices downstream without any additional programming or uh, without the additional of a new gateway to those following devices. So it's very easy to implement. So as I was mentioning earlier, if you have put a drive onto Studio 5000, it's a similar process. You're going to go to your, in Studio 5000, you're going to go to your network and then hit discover. You'll be able to find the gateway. And then from the gateway, once you click on that, it's going to create a subnet. And then you can discover all your devices downstream of the gateway if it's already wired up. All this requires minimal learning and training time. I have been able to program this in about 10 minutes after 3 to 4 hours of training. You will need to get an add-on profile if you're using, I think, version 36 or 37 of Studio 5000. I believe newer versions of Studio 5000 will have the add-on profile already programmed in. With all that data back, there's now easier ways to read it. And there are, say, if you're pushing it onto an optics panel, you can see these existing pages. So these will be able to give you insights into what's going on with your devices downstream. This will enhance your device level diagnostics with new connectivity to the 140ME motor protection switching devices and the 100E electronic overload relays that provide real-time visibility into your network. There's expanded fault and event reporting, enabling faster troubleshooting with clear root cause insights across connected components. There's integrated analytics support, predictive maintenance by monitoring trends such as load, temperature, and communication quality. So all this is going to be able to feed back to your PLC or an optics panel or wherever you're storing your information. So these are the expected business outcomes from using Ethernet IP and cabinet solution. We expect you to have reduced wiring time and panel footprint. This is going to mean you spend less time on the platform wiring these up, and you're going to be able to buy smaller panels where you're able to reduce the amount of raw material required to build a panel. It allows you to simplify designs and your deployment. Running one cable is much easier than running, say, if you have 39 devices and each one of them has power and ground. That's an additional 40 cables versus one cable. Additional 30, 60, 78 cables versus one cable. Sorry. You're able to operate more sustainable because once again, you're able to additionally program on new devices onto your existing gateway rather than say ordering new digital I/O cards or cutting new holes. You can also use less raw material, making this device more sustainable over standard practices. There's also improved performance and data visibility. So you get to know when your device is about to crash rather than thinking, hey, that's an old panel, let's replace it. You can see how many times each of these operators say have been used. There's significant time savings going with this device. So it is an investment to go into the Ethernet IP solution, as it's going to add a little bit more cost to every single device. But you're going to get this back from your ability to do more jobs in the same amount of time. So there's a 66% reduction in wiring time, a 50% reduction in testing time, and a 30% reduction in engineering time. These numbers are from not Rockwell, but a Rockwell partner, Volga. They have simplified the design going to Ethernet IP and cabinet solution and saw these time savings. And it's not the only customer that's doing this. Controversial is also the world's largest polymer manufacturers, and they have deployed Ethernet IP and cabinet solution and found a 60% reduction in wiring time. So you can now take a job that used to be about a week long of one person and now make it into a 2-day job, uh, taking it from 16 hours to from 40 hours to 16. So once again, the Ethernet beam cabinet solution is more sustainable. It is more sustainable because it minimizes the sizes of your panels, reducing the general waste while constructing a panel. There's also modularity and scalability of the solution, allowing for easier upgrades and maintenance, reducing the need for complete replacements and minimizing environmental impacts of surplus components over time. By reducing the complexity of your control wiring during a project's electrical design, you can sustainably lessen the amount of wiring, cable, and copper required. And there's a overall smaller panel requiring less raw material for construction, leading to lower resources consumption and waste. So once again, it used to be 78 wires, now it's down to 1. For some customers, sustainability is a very key point when talking to customers. So here's another quote from Volga. Some of our customers, the first point to them is sustainability. We'll be talking to our customers about the technology that reduces cabling and copper and reduces the impact on the environment. And then here is a list of additional resources. You can find some on YouTube, on RA, and user manual. If you ever need this, you should be able to find it in the link below this video. And now that this presentation is done, I'd like to show you a little bit about hardware we have. Hopefully I'm big for everyone, like I'm center screen. If I'm not, please someone raise their hand.
You're good, Peter.
So this is some Ethernet IP and cabinet hardware. Up here, you can see our push buttons, illuminate push buttons, non-illuminated push buttons, and a switch. Here is a motor starter. This is a combined overload and breaker. And then here is a reversing starter. I can control this reversing starter with this switch. And I'm using this push button as an indicator. As you can see, it changed colors. Each one of these LEDs, illuminated LEDs, are going to have 8 configurable colors. So you can see I have it changed to different colors depending on which direction it's going. And then this one, I have a toggle button, and it's now controlling this motor starter. And I can toggle it off. And then say if there was an overload, you can see now this indicator button has also changed colors again. I can turn that back, and now the motor starts ready. And then just here's a few more colors. Once again, this is the gateway. This is going to be using they're going to be using these clips, which goes onto a ribbon cable. The ribbon cable are sold in schools like this. You can then cut it to length with standard scissors. And to apply a node to the wire, you're going to make sure this gray line is at the top. You're going to take this clip, put it in like this. And now it's latched in. You close this and clamp down with standard pliers. Once it's clamped down, it's going to bite in. These are single use, so if you clamp this down, I can't take it off and reuse it, so I'm not going to do that right now. And then if you want to put an extra node, you want to make sure it's at least this far apart, which is going to be about 50 millimeters for every single device. Once it's clamped down, be able to pull off the back. This device is going to go into whatever is available, and you can put it in there. But right now, I want that, so you can see that indicator turn on and off. These devices here are communicating peer-to-peer. So this gateway is holding the program that I wrote for in Studio 5000. So all these devices are acting locally, and there's no PLC in the system. This is just a power cable. And once again, you can still see all these devices are working fine. These can also be controlled with a PLC. So if you don't want to use peer-to-peer, that's fine. And then you can also see I have these two cables running, which is giving me the indicator of whether or not this breaker is blown. And this is going to be how you get your buttons to work, your 800F buttons. As you can see, I have a standard contact shoved onto one of these buttons. So if I wanted standard contacts to go with the Ethernet IP and cabinet solution, that's perfectly fine. It doesn't work with safety ones yet, as they're a little bit too tall to squeeze in next to this, but you can put on, once again, 2 different contacts per button. They pop on and off. Do I have a screwdriver? Yeah, I can't get it off right now. But this is just going to be your standard latch, so I can get it off like that. So this is your standard push button 800F operator. This is your plastic latch. It could also be a metal latch. And then this device just hooks onto the back of it. And push that back on. So the gateway does need a power supply, so that's why I have this. And it's always good to have a breaker. So I have this before your breaker. If you are interested in the Ethernet IP devices and you're in New York City area, please reach out to Turtle or contact your local Allen Bradley distributor. Does anyone have any questions? Great.
All right. Thank you so much for joining us for Talk Tech with Turtle every other Tuesday at 10 a.m. Join us on June 1st for IMA and Remote AOP with Lifecycle Services Manager William Nieves. Thanks so much, everyone.